Hello guys, welcome to the mathematics lesson. This is the lesson number 2 on the matrices. Remember we started yesterday looking at matrices and this is lesson number 2 with me, your teacher, the DMS online school teacher, Mr. Masumba, if you don't mind. So today we'll be looking at the multiplication of matrices. So we're looking at multiplication. Okay, so that's what we are looking at, multiplication of matrices. So you must understand that matrices also can be multiplied if the number of columns in the first matrix is equal to the number of rows in the second matrix. So two matrices can be multiplied if a number of rows or number of columns in the first matrix is equal to number of rows in the second matrix. Yeah, so if number of columns in the first matrix is equal to the number of rows in the second matrix, then those matrices can be multiplied. So how do you multiply? You multiply columns with rows. So we multiply, okay, columns in the first matrix with the rows in the second matrix. So without wasting much of the time, let me give you some examples. Okay? So let's look at example. So this says simplify the following. So we have A, we have a 1, 3, then negative 2, then 2 like that, then multiplied by, then we have 4, then we have negative 5. Then B, we have 1 and 2, then multiplied by, we have 3, 0, then 2, 4. Okay? Let's first look at these so that we see how we can implement this. So, before we do the multiplication, does this satisfy this condition that condition 1, that the number of columns in the first matrix is equal to the number of rows in the second matrix? Then if that is correct, then we multiply columns in the first matrix with the rows in the second matrix. So we check Here we have how many columns? 1, 2. Here we have how many rows? 1, 2. So these columns are equal to the rows. These two matrices can be multiplied. So we multiply the column with the rows like that. So you get the column with the rows and then this column with the same rows. So say equals. So this is how we are going to sum 1 times 4. So you sum 1 times 4. When you say plus, you get this one. 3 times the negative 5. So say 3 times the, then you say negative 5. Then you come to this, the same one, negative 2 times 4. So say negative 2 times 4. Then plus, then you say 3 times negative 5. I mean 2 times negative 5. So 2 is times negative 5. Then once you do that, you also do like that. So this is step number 1. Then step number 2, you say, okay, this one, you say 1 times 4, which will be 4. Then 3 times okay, you can say positive 3 times negative 5, which will be negative 15. So you put negative 15 there. Okay. Then here you say negative 2 times 4, you have negative 8. Then positive 2 times negative 5, you have negative 10. So this will be negative 10. Okay. Then you close like that. Then what you do lastly is this. You say 4 minus 15, which will be negative. Then you say 15 minus 4, it will be actually 11. Then negative 8 minus 10, it will be actually negative 18. So this one will be negative 18. So this will be the final answer like that. Okay? Then we move to the, we are multiplying this matrix with this second matrix. Again, for this to qualify, unless the first condition is satisfied, is it true that the number of columns in this first matrix is equal to the number of rows in the second matrix? Well, let's check. How many columns are here? We have actually 1, 2. How many rows are here? 1, 2. So since the number of columns are equal to the number of rows, then these two matrices can be multiplied. So what are we going to do? We can do like this. So say equals the number of columns by the rows and the same column by these rows. So say, okay, we'll have 1 times these 3 here, then plus this again 2 times 2, 2 times 2. So we have said 1 times 3, then plus 2 times 2. Then again you shift 1 times 0, you say 1 times 0, okay? Then you say plus 2 times 4, 2 times 4, okay? Sorry. So you're saying 2 times 4. Okay, I think this will just be like this. Yeah. Then the next thing that you're going to do is this. So say 1 times 3, which will be 3, then plus, then 2 times 2, which will be 4. Then here you come, 1 times 0, it will be actually 0, then plus, then 2 times 2, which will be 8. So you can close like this. It's very important that you don't skip any steps because usually when you are skipping steps, you are likely to make mistakes. So you say equals, you say 3 plus 4, 7, then 0 plus 8, which is 8. So this will be the answer. Okay. So we move to the next example. which is C because I never wrote C here. So C C was like this. We have 1, 3, then 2, 4, multiplied by, you have 0, 1, then you have 1, 2. So again, we have to check. For us to be able to multiply these two matrices, we must ensure that the number of columns in the first matrix is equal to the number of rows in the second. So here we have columns 1, 2, here we have rows 1, 2. So since this first condition has been satisfied, then we can now multiply the columns with the rows. So it will be like this. So say equals, so say 1 times 0, so we say 1 times 0, then plus 3 times 1, 3 times 1. We are done. Then we are shifting to the second. So as you shift to the second row, you don't do plus. That is very clear. You only do plus when you do this one and this one plus. But as you shift to the next row, don't do plus. You just say 1 times 1. You say 1 times 1. Then now plus, as you get now, 3 times 2. So say 3 times 2. Okay? Then you are done. Then you come to 2 times 0. So say 2 times 0. Then as you come to 4, you say plus. Then 4 times this one here. Say 1. Then you shift to this one. So say 2 times 1. So 2 times 1. Then plus 4 times 2. 4 times 2. So notice here we have 2, 2, 1, 1, 1, 1, 0, 0. That will always be the pattern. Okay? So you put the brackets, then you say, okay, equals. So you say 1 times 0, 0, then plus. Then you say 3 times 1, which will be 3. Then here 1 times 1, which will be 1. Okay? Then 3 times 2, which will be 6. So plus 6. Then here 2 times 0, it will be actually 0 plus. Can you just give space here? Yes, so I'm saying 0 plus 4 times 1, which will be 4. Then 1 times 2, which will be 2, plus 4 times 2, which will be 8. Okay, so you put it like that. Follow step by step, don't rush. So you say equals, then you say 0 times 0 plus 3, you get your 3 there. Then 1 plus 6, you get your 7 there. Then 0 plus 4, you get your 4 there. Then 2 plus 8, you get your 10 there. So you put like that. Okay? So that will be the answer here. Okay? So this is how we do multiplication. So make sure you master, you don't forget. Okay? So now let's look at the next part, which is which which is determinant of a matrix. Before we do that, it's actually in our identity matrix. So we are going to look at identity. Okay. So it's very, very important that you know what an identity matrix is. So I will maybe explain just. So an identity matrix is a square matrix in which the major diagonals are ones and then others are zeros. So like an identity matrix is denoted or symbolized by I. So an example of an identity matrix I, which is an identity matrix, is a matrix in which the major diagonal has 1, then all the rest are 0. So you have 0 here, then here you have 0, then here you have 1. So this is an identity matrix. So these position here, they are called diagonals, major diagonal, and these are minor diagonal. And if you have ones in the major diagonal and the rest are zeros, then you have what we call an identity matrix. So it is very, very important that you understand what it is. Okay? So now, in general, if you get an identity matrix, you multiply it with another matrix A, which is the same as getting matrix A, you multiply it with an identity. So this is just a commutative property of multiplication. So remember, multiplication is commutative. What I mean by commutative is if I get 2, if I write 2 times 3, it is the same as saying 3 times 2. Because if I say 2 times 3, what am I getting? 6. If I say 3 times 2, what am I getting? 6. So this is the same property that I'm using here, where I'm saying that, if you get an identity matrix, you multiply it with a matrix A. It is the same as getting matrix A, multiplying it with an identity. And the answer that you get is going to be always equal to A. Okay? That's what it means. So, e.g., let me give an example so that we understand. Example. So here is an example. We have matrix A is equal to maybe 2, 3, then 1, 0. Then we know an identity matrix I is always 1, 0, 0, 1. Now, if we get I times M, we mean that we are getting I, which is here, we put it here, 1, 0, 0, 1. Then we are multiplying it. That's what it means. It means I times A. So we are multiplying I, it is this one, we have substituted. Then A, we put this one here. So we say 2, then 3, then 1, 0, like that. So we can multiply these two because the number of columns here is 1, 2. The number of rows is 1, 2. So let's see if we are going to get matrix A. If we multiply this times this, the answer should be this matrix A. That's what it means here. So let's try. So by multiplying also 1 times 2, so say 1 times 2 plus 0 times 1, so 0 times 1. Then we'll shift 1 times 3, 1 times 3, then plus 0 times 0, 0 times 0. Then you come here, 0 times 2, 0 times 2. And let me just extend this one. It may not put them very close, so you see 0 times 2, then plus 1 times 1, 1 times 1, then 0 times 3, 0 times 3, then plus 1 times 0, 1 times 0. So close. Then I'll make sure that I'll say 1 times 2, 2 plus what? 0 times 1, which will be 0. Then here 1 times 3, which will be actually 3, plus 0 times 0, 0. 0 times 2, it will be actually 2, plus 1 times 1, 1. Okay. Then here we say 0 times 3, it will actually be 0, plus 1 times 0, it would actually be 0. So we'll close. Then we are going to add 2 plus 0, 2, 3 plus 0, 3, 1 plus, and 2 plus the 1, 3, okay? 2 plus 1, 3, if you have not made a mistake. Sorry, here there is a mistake, because we said 0 times 2 should be 0, okay? Here. Then 1 times 1, 1. So we say 0 plus 1, it is going to give us 1. Then 0 plus 0, 0. So now, if you will check this matrix we have gotten, and these, are they the same? This and this are the same. Okay? This is 2, 3, 1, 0, 2, 3, 1, 0. Therefore, this property is correct. When you get an identity, multiply it with any matrix, the value that you are going to get is that very identity matrix. It's a very important. So this is how we should know an identity matrix to be. Now, having just shown you an identity matrix, now we are going to move to a determinant of the matrix. So we are looking at the determinant of a matrix. So what is the determinant of a matrix? It's just a product of elements in the main diagonal minus product of the elements in the minor diagonal. So that's what a determinant matrix is. When you get the product of the elements in the main diagonal minus product of the elements in the minor diagonal, that answer which you are going to get is what we call a a determinant of a matrix. So determinant is denoted by dE. So determinant of a matrix is denoted or symbolized, denoted by DET. That's the one we use to show a determinant. So for instance, each, if we have matrix A, which is equal to, maybe it is A, B, C, D. This is the matrix. Then if they ask you to say, can you find the determinant of matrix A? So we are going to say determinant determinant of matrix A is denoted now, will be denoted or symbolized by as follows. Denoted as D, E, T, then A. So is given as shown. So this is how we are going to give. So we'll say D, E, T of A, which can be read as a determinant of matrix M, is going to be product of elements in the main diagonal. So this is the main diagonal, like their product means A times B. Then minus the product of elements in the minor diagonal. So the elements in the minor diagonal are these. So say B, oh, this is A, D, okay? A, D times now minor is BC. So say B times C, like that. That's how we do it. So this will become now the determinant of this. Very important for you to keep this as a general formula that will guide us whenever you are asked to find the determinant of a matrix. This is what guides us. So now let's look at an example. Here is an example. So this example says find the determinant of matrix A, which is given as 2, 3, then 1, 4. So we have this matrix, then we are asked to find its determinant. How are we going to put it? So in answering here, we just say determinant dt of matrix A will be equal to elements in the major diagonal, products of elements in the major diagonal, which will be 2 times 4, then minus the product of elements in the minor diagonal, which is 3 times 1. So say 3 times 1. So which will be equal to 2 times 4, which will be 8, minus 3 times 1, which will be 3. Then 8 minus 3, which is going to be 5. So this one, therefore, say therefore, this is the determinant of matrix A, like that. Okay? So these things are simple, guys. Very, very simple. Now, a matrix whose determinant is 0 is called singular matrix. Okay? If you discover that you find the determinant it is 0 here, then that matrix is called a singular matrix. Now let's look at what we call an inverse matrix. Okay, inverse matrix. So, an inverse matrix is a matrix which when you multiply it with another matrix, the result is an identity matrix. So an inverse matrix is one. If you multiply it with if you get, for instance, if you get matrix A, you multiply it maybe with the matrix B, then the answer is going to give you an identity. Then we'll conclude that therefore, we'll conclude to say therefore, either matrix A is actually the one which is an inverse matrix, or it is maybe matrix B which is also an inverse matrix. So this is an assumption now. The main important point is this. If you get two matrices, you multiply them, and then the product or the value that you get, the result, the answer is an identity matrix. Then either of those matrices, one of them is an inverse matrix. And an inverse matrix is denoted by this. Let's say, suppose we have matrix A, which maybe is given by, let's put some letters, just A, B, C, D, like that. Okay? So suppose we have matrix A, which is given by that. Then its inverse is denoted or represented as shown. Denoted as A, like that. A to power negative 1. So that this one becomes the inverse of that. Now, how do we find the inverse matrix? So we are saying in general, the inverse matrix of matrix A can be found as shown. So this is how we can find it. We can say inverse of matrix A is going to be equal to 1 over determinant of matrix A, then open brackets, we swap these elements in the major diagonal. D comes where there is A here, then A comes where there is D. Then we put negatives to these which are in the minor diagonal. So we have negative B, and here we can have negative C. This is the formula for finding the inverse of a matrix. Any matrix that you are given can work using this formula here. So let's look at an example. So these examples is have two examples actually. Example 1 says if M is a matrix which is equal to, open brackets, we have negative 1, then 3, then we have 1, then 2. And the question says find, the question asks us to find 1, Roman numeral 1, M squared. Then 2, we are told to find the determinant of M. The determinant of M. Then 3, we are told to find M to power 1. So M to power 1 is the inverse. Okay, let's look at solutions here. So 1, they want us to find M squared. M squared, M, you see, if M is equal to this, then they say find M squared. It means it's same equals M is this one here, okay? So open brackets, negative 1, then 3, negative 1, 3, then 1, 2, you close. Since it is square, given here you put in square. Now square it means you are multiplying this matrix by itself. So you say this also means we are getting the same matrix, which is negative 1, 3, then 1, 2. Okay, we are multiplying it with itself twice. We are getting again negative 1, then 3, then 1, then 2, like that. That's what this means. Very important to understand these things. Then I'll drop it here because of space that side. So this multiplication now comes in. That's why we learned multiplication, very important. So say negative 1 times negative 1. So say negative 1 times negative 1, then plus this 3, this 3 times 1. And you say 3 times 1. Then you shift again, negative 1 times 3, negative 1 times 3, then plus 3 times 2. So say 3 times 2. Then you come to this one, 1 times negative 1, so say 1 times negative 1 plus you come to this to solve. I've said 2 times 1, so say 2 times 1. Then you say 1 times that 3, 1 times 3, then plus 2 times this 2, 2 times that to solve. We'll close like that. Then we'll continue. So say negative 1 times negative 1, it is positive 1. Then plus 3 times 1, it will be 3. Then here negative 1 times 3, it will be negative 3. Then plus here 3 times 2, it will be 6. Then here negative 1 times 1, it is negative 1. Then plus 2 times 1, it will be 2. Then here 1 times 3, it will be 3. Plus 2 times 2, it will be 4. Then we'll put like this. Then we'll continue. 1 plus 3 will get 4. Then negative 3 plus 6 will get 3. Then negative 1 plus 2 will get 1. Then 3 plus 4 will get 7. So this will be the final answer for multiplying for m squared of this. So it's very, very important that you get to understand these things. Okay? Then this is one. Then number two, they're saying we find the determinant of m. So we have found one, then we are finding the determinant. So I can just rub this one. And then find number two. Number two, the one is the determinant of m. So determinant of m, remember, we said it will be determinant dm is going to be equal to, you get the elements in the major diagonal, you multiply them, like 1 times 2 minus, so 1 times 2 minus 3 times 1. So 3 times 1. So say equals 1 times negative 1 times 2, it will be negative 1. Then minus 3 times 1, it will be 3. So it will be equal to, so I say minus 1 or negative 1 minus 3, it will be negative 4 as the determinant. Okay? Okay. That's why checking is very important. So I've just made a very useless error. So negative 1 times 2, it will be negative 2 minus the 3 times 1, it will be 3. So this negative 2 minus 3, it will be negative 5. So this is a determinant of m. Then 3m to power negative 1, it means the inverse. So for us to find the inverse, remember the inverse, I told you this should be the part of the formula for the inverse. So number 3, we are finding the inverse. So inverse, which is m to power negative 1, should be equal to 1 over determinant of m, then open brackets, you see the way it is finding the inverse. So a, so m, then open brackets, we got a here, we swapped this came here, this one here, like that, we put a negative here. Now we are dealing with m, so we'll get m, this comes here, this comes here. So put a 2 there, a negative 1 there. So we have swapped, this has come there, this has come there. Then we put negatives to these which are already existing. So we'll have negative 3, and then this one will be negative 1, like that. Okay. Now, here on the determinant, this determinant of m is this, which we have found as 5. So we substitute. So say equals, we say 1 over this 5 here, negative 5, open brackets here, we just put 2, negative 3, negative 1, negative 1. Then now we'll multiply. This will mean this one is like a scalar. Okay, it's a number which will multiply with everything inside the brackets. So you say 1 over negative 5 times 2, it will be actually negative 2 over 5. So this times this is this. Then this times that, it will be positive 3 over 5. This times that, negative, negative, positive. So 1 times 3 over 5. Then the same 1 over negative 5 times that, negative, negative, positive. So you have now 1 over 5. Okay? The same 1 over negative 5 times that negative to be the same 1 over 5. This will be, therefore, this will be the inverse, like that. Okay. So now we move to, this was example 1. I said there are 2 examples, so I can give you another example, which is example number 2, which I have here. Okay. So if you are following steps very well, mathematics was meant to be enjoyed. So example number 2 we are told given that A is equal to 3, 7, then 2, 5, and the same find 1 over numeral 1, the determinant of A. The determinant of A. Then 2, we have to find the inverse of A, which is the inverse of A. Then 3, we have to find the value of the inverse of A times negative 2 and 1. Okay. So these are the 2 examples. So this is example 2. So we are told, given that A is this matrix, find the inverse. So solutions, or say 1, they are saying find the determinant of A. Determinant of A, we say it should be DTM is equal to elements in the major diagonal, the product which will be 3 times 5 minus elements in the major minor diagonal, the product, so we have 7 times 2. So say, okay, equals 3 times 5, which will be 15, minus 7 times 2, which will be 14. Then we'll say 15 minus 14, 1. So say, therefore, determinant of A is this answer we have found. So that's how we find that one. Then on part 2, did we find it here? From here, they're saying inverse of A. So the inverse, which is written like this, we said it should be 1 over determinant of A, open brackets. Since A is this one, we swap this one comes here, this one comes here, so we have 5. Then here we have 3. Then here we give negatives here, so we have negative 7. Then here negative 2. Then we close. Then we'll say equals. Now when you check, here we have found the determinant, which is 1, meaning here where there's DEA determinant, we have already found it here. It is 1. So just say 1 over 1, open brackets, we have 5, negative 7, negative 2, 3. Now this one is simple because we have a 1 here. So you must understand that this one will be like this. 1 into 1, what do we get? 1. Then 1 times now this 5, negative 7, negative 2, 3. Okay? So you say 1 times 5, 5. 1 times negative 7, negative 7. 1 times negative 2, negative 2. 1 times 3, it will be 3. So say therefore, the inverse of matrix 1 is this answer here. So simple, guys. Then we go to 3, the value of inverse multiplied by that. So 3, they're saying we find the value, meaning if we get the inverse of A, we multiply it by negative 2, 1, we should find the value. So it means we get the inverse here, we should put the inverse, which is the inverse is this one here. So where there's this one, we'll put this. So put 5, negative 7, then negative 2, 3. Then the same we multiply now with this negative 2 and the 1. So say equals. So what we are going to do, can we multiply this matrix with that? Let's check if the number of columns here are equal to the number of rows. So this one, here we have how many columns? So 1, 2. Here how many rows? 1, 2. So these are equal, we can multiply. So we can say now 5 times the negative 2, then plus negative 7 times, okay, like that. So it's saying negative 7 times 1. Then we'll also say negative 2 times 2, negative 2 times negative 2, then plus 3 times 1, 3 times 1. Then we'll do it like that. Then we'll come and say 5 times negative 2, it will be negative 10. Then we'll send Negative 7 times 1, it will be negative 7. Then that negative 7 times positive here, it will be actually negative 7. Then here, negative 2 times negative 2, it will be positive 4. Then plus, then 3 times 1, it will be 3. So I'll do like that. Then you say equals, then negative 10 minus 7, it will give us negative 17. Then 4 plus 3, it will give us 7. So this one will be our final answer. So that's how we do with matrices. So let me see if I have more examples to give you. Okay, I have another example 3. There's a reason why I'm giving you another example, so that when I give you an exercise, you'll be able to understand. So this one is example number 3. So write example number 3. We are told that N is equal to 5 negative 2, then 3, then here x. This is why I have decided to show you this one. And then, and b is equal to, we have 6, and then 4, like that. Then the same, given that number 1, or Roman numeral 1, the same, given that the determinant of A of matrix M is 21. Then the same, find x. So we should find this x here. Then part 2 the same, hence find the inverse of matrix M. Then 3 the same, find A, B. It means matrix A times B. Matrix A times C, that matrix A, B. So let's see how we can do these solutions. So we are dealing with Roman numeral 1, where we are told that the determinant of matrix M, you write the determinant of matrix M is equal to 21. Okay, that's what it has said here. But then they want us to find the value of x. So for us to find the value of x, we must first of all know what is the determinant in this one. So we say, okay, the determinant in that one is going to be here. Okay, before we do that, maybe I do it in this way so that we don't do a lot of things. So we'll go straight. Determinant of this, we'll deal with this one, is this times that, where we say 5 times x minus negative 2, or I can 3 times negative 2. 3 times negative 2, like that. And I'll say this now is also equal to 21. Because here it says determinant of A, we know we can find this times that minus that one, which is this one. But it is also now equal to the final value they have given it to us. So now it means here we say 5 times x. So we'll do it like this. This implies 5 times x to be 5x. Then here we'll say negative times negative positive. Then 3 times 2, it will be 6. Then we'll say equals 21. Then this one becomes a mathematical equation where we need to solve for x, because we are saying find for x. So to find for x, we collect like terms, like numbers which are constants must be on the right side of the equal sign, and then on the left side of the equal sign, we have to remain with the term with the unknown. So this one will also have 5x equals, we have 21. Then this one crosses, it becomes negative 6, from positive to negative. Then we'll say, okay, 5x is equal to 21 minus 16, it will be 15. Now for us to remain with x, unless we divide by 5, this side, and also this side by 5. So 5 into 5, it will go, or remain with it. X is equal to 5 into 15 is 3. So we have found the value of x. Now, number 2, they're saying hence find the inverse. So, number 2, for us to find the inverse of m, is the inverse of m is equal to determinant, oh sorry, not like that, is equal to 1 over determinant of a, then open brackets, we need to get this one comes here, this one here, we'll have x, then that 5 comes here, then this one becomes negative. This one is already negative. If we add another negative, it will be positive, so it will now be positive, like that. Then we'll say equals 1 over, remember determinant A, we were already told it's 21, so you put 21 and open brackets. X, we need to put the actual value, which is 3. X is 3, so we put 3. Okay, like that. Then 2, then negative 3, then 5. Then now you go ahead, you say 1 over 21 times 3, it will be like 3 over 21. Then 1 over 21 times 2, it will be like 2 over 21. Then 1 over 21 times 3, it will be negative 3 over 21. Then 1 over 21 times 5, it will be 5 over 21. If you want, you can leave your answer here, that is the inverse. Or now you can say 3 into 3, 1. This 3 into 3, 1 over 3 into 21, 7. Okay, this one you can't reduce it, you leave it the way it is, 21. Then here, negative 3 into 3, 1. 3 into 21, 7. So put 7. This one will remain 5 over 21. Okay. So times will be the inverse. So say, therefore, the inverse of A is now going to be that answer. Okay? Now, we are remaining with the last one so that I give you an exercise. So the last one says we find A times B. So say equals A, it is this one. So A will put 5, -2, 3. Where there's x, we have found that it is 3. Then we say times. Where there's b, we'll put that one, open brackets, 6, 4. Then we need to multiply. Since the number of columns 1, 2 is equal to the number of rows here, we can multiply. So say equals, so 3 times, 5 times 6, so say 5 times 6 plus the -2 plus times 4. Then we'll say again here 3 times 6, 3 times 6 plus 3 times 4. So say equals 3 times 6, 5 times 6, 13. Then -2 times 4, -8. So here it will be -8. Then here 3 times 6, it will be actually 18. Then 3 times 4, it will be 12, plus 12 like that. Then we say equals 30 minus the 8, it will be actually negative, it will be actually 22. Then 18 plus 12, it will be 30. So therefore, we can say therefore, A, B will give us this answer. Okay, so now we have come to the end of this lesson, but I need to give you some exercises also for you to do so that you can practice. Remember, practice makes it perfect. That's how life is. So here is an exercise for those doing online tuitions. The exercise is here. So this is A, not 9, AB. Okay, so these are the questions that I've given you guys to practice. These are actually examination questions that I've picked from the topic on the matrices. So try to answer these questions and try to submit the week for checking for those that are in my online group for mathematics. For now, bye. Thank you for watching. See you in the next lesson.